So in this video we are going to solve question number 29 of TIF for 2020. The question asks that methyl groups in the following compounds are diastereotropic, anisotropic, diastereotropic or something else. So the question asks about topicity, right? Topicity of methyl groups. So to solve this question, I have drawn this molecule here, and what we actually do here is to change the one methyl group, changing one Ma group by, let's say, X. So what we have X here, and this is methyl group, this is our NH2 group, and this is our COOH group here. Okay, and if we change this methyl group, then what will happen? It will be like this one. Okay, now you can see that this is a tetrahedral center, this is a tetrahedral center. So let's say here this bond or this CH3C bond is in wedge form. Okay, and on the below is hydrogen in the dashed line or dotted line. Here will be hydrogen. Similarly, it will also be in the wedge and dotted, dashed hydrogens. So to check whether they are enantiomer or diastereomer, we need to convert it like this. I am just rotating this bond. Fixing this point, I am rotating this latent portions of this molecule, so that I have here X, here NH2, here COOH, right? And here I have in the wedge form hydrogen, and in the below form I have CH3 group, right? So now just check whether they are enantiomer or diastereomers or homomers, that is identical. So definitely look at that. Here NH2 and methyl groups are in the wedge form, but here NH2 and hydrogens are in the wedge form, right? And they are diastereomeric in nature. They are diastereomer. Okay. If we consider why this is so, we can also do it. Normally, here we have substituting. We are uh, setting this X by replacing CH3. But how this is? This X have greater priority than methyl group. Okay, X has greater priority than methyl group. According, okay, so leave it. So here X is number 1, this is number 2, but not like that. Not like that. Here is carbon, right? And here it is CH3. Okay. Now it has nitrogen, it has hydrogen, so it is number 2. Okay. Here one thing is noted that X has greater priority than methyl group, but okay, without affecting other group, right? So here this one will be 1 and this one will be 2, this one will be 3 and this one will be 4. So the rotation will be like S. It has S confirmation, sorry, S configurations, right? S configuration. And for this carbon, this is also tetrahedral and this is also chiral center. So NH2 is getting here 1 and COOH getting 2 and this one is 3 and hydrogen is 4. So that I have similar S configurations. So I have in this molecule that is S configurations. Okay. Now let's check this one. You can see that the right hand portions is similar. So right hand portion is S, but in the left hand portions that is V equals to 1. Okay. Here we will get this one will be 1, this one will be 2, this one is 3. But hydrogen is in front of us, that is a least priority group, so that we have here 1 and here 2, here 3, that is S, but the opposite one will be happen here, that is R. So this is RS and that was SS. So the relation between this is just diastereomer, right? So how the diastereomer is coming, I have shown here by RS descriptors. So here the relationship between these two methyl groups is nothing but diastereotopic. So in option A that is diastereotopic, in option C that is diastereotopic, but B and D there is no such relations like diastereotopic. So now let's check second molecule. Okay, let's check second molecule. The second molecule is DMSO. Okay, but if you know the VVD concept that sulfur has like 3s 3p, right, and it has also 3d. This is 3p, this is 3d, right? So 3s2 3p4, 1 2 3 and finally 4. So here what may happen, this will promote is its electron to the 3d level to form 1 pi, I mean 3 sigma bond and 1 pi bond, so that it will promote its electron to the 3d level and it will like this and this. So it will form here CH3 sigma bond, here CH3 sigma bond, and here sigma 2 oxygen and then pi bond, right? And it has a lone pair of electrons that is missing in the structure which is given in the question. Somebody says that here is also plane of symmetry, I mean here is C2 axis, C2 principal axis, but that is not correct, right? So it has lone pair of electrons here and this is tetrahedral in nature. Okay, so sulfur here is, and this is lone pair, this is double bond, this is double bond, right? So if you consider here, sorry, this is CH3. So now changing one CH3 into X, so that may be transformed into S. Here this is, okay, sorry, it is single bond, it will be sigma bond, right? Okay, so it will be, let's say X, this is CH3, I am making it wedge form, and okay, a dash form here. So now it will be like dash form and this is wedge form and this is lone pair of electrons. Now changing another CH3 here, that will be SO. Here it is, sorry, it will be X now here. This is CH3 and this is our lone pair of electron. Now if we check the relationship between these two that means this one and this one, you will find that the relationship between these two forms is enantiomer. Okay, because this one is a mirror image of this one. Okay, so that the relationship between these two CH3 groups will be enantiomeric, I mean enantiotopic. And they are enantiomer. Okay, these two are enantiomer to each other. So here it is enantiotopic. So let's check which options we have. So option A is enantiotopic, option B is neither enantiotopic nor diastereotopic. So option A is the right answer of this question number 29. Okay, no need to check out the third molecule here because we have our answer here. So option A is the right answer of this question number 29. Option number A. Thank you so much.